Hello, everyone. Welcome to our talk. We're about building globally resilient control planes. I'm Stephen Borrelli. I'm a principal solutions architect at Upbound, and this is my colleague Yury.
Hi, everyone. I'm Yury. Thanks a lot for joining our talk today. So we are from Upbound, and if you heard about Upbound, you probably know that we are creators, as a company, we are creators of Crossplane project. And today we are going to combine the power of two projects of Crossplane and K8gb. And K8gb is a project that was created by me in an organization before Upbound in APSA. And basically currently it's also CNCF sandbox project. And I'm really excited about the opportunity today to show the powerful combination of two projects coming together. So Steven, please kick us off.
All right. Hello, folks. So the first thing I want to talk about is just some of the really basics of building infrastructure platforms. And this is really simplified, but just talking about some of the kinds of major use cases that we see. The first one is obviously end users, and these are the folks who consume the applications that the organization provides. The second group of users are developers. As platform engineers, these are some of our our most important users. We structure a lot of work around them, and their main goals are to be able to deploy code using CI/CD systems and also request infrastructure. This is a big thing for Crossplane, that allowing developers to self-service infrastructure. And then finally, platform engineers. Yury and I are both solution architects, so we kind of do a lot in this role. And this is basically the folks who are building these platforms. And it's very important for us, like, how do we structure these so that they scale and also that we could fail them over. Our goals today, we have a demo, we've written some code, but basically the idea for this demo today and the project that we're working on is we want to not only do workloads, but also infrastructure provisioning. We actually want to have two clusters that's doing this. We want to have an active passive model, even for the infrastructure management. And what we're going to do is we're going to key off the active and passive failover based on the health of the application that we're managing. And the way we're going to do active passive failover is we're going to do DNS-based. Right, so that's part of the strength of the K8gb project, is using DNS to have global failover. So the core technologies, as we said, one of the chief architects of the K8gb project, this is a global load balancer that runs on a Kubernetes cluster. And the second one is Crossplane, which has been mentioned a few times here already at the conference. Crossplane is a universal control plane. It extends Kubernetes to be able to manage anything. Okay. So this looks like a very complex diagram, and this is kind of the architecture that we're going to be showing off today and deploying. And I'm going to walk through it very slowly, so I know it looks very intimidating to start. But what we're going to do is we're going to walk through each one of these blocks, and kind of hopefully towards the end you will understand everything that's going on. So the first thing I want you to see is that there's two clusters, Cluster A and Cluster B, that'll be running our workloads and doing infrastructure management. Each one of these clusters has several namespaces. So the first one we're going to look at, the first namespace is a Crossplane one. This is the one that's doing all the infrastructure provisioning and app deployment. So you could see it up there with the popsicle, the Crossplane logo. And the key things to know about here, what's running in this namespace, is Crossplane itself. And then Crossplane has two types of extension points. There's functions, and functions are almost like a Lambda. It's a serverless that we use to actually create all the desired states. So what happens is Crossplane sends the request, the YAML, and then the function can be written in any language, and it returns all the YAMLs, all the manifest of all the resources that need to be created. So this is an incredibly powerful way of being able to define infrastructure in any language. The other extension point is a provider. A provider basically allows you to talk to different types of APIs, right? So we have hundreds of providers that talk to all the major cloud providers. So that's Crossplane. The next thing I want to talk about is the K8gb. So it's also deployed in its own namespace, and there's three major components to this. First, it's the controller for K8gb itself, and it provides one CRD. And then there's two components that are based on that. One is a built-in version of core DNS that dynamically updates. This version of core DNS actually has an ingress that you will talk to. This will actually present the DNS server to the world from your cluster. And the other one is external DNS, another famous Kubernetes project. And this is actually used to update cloud resources like Route 53 dynamically based on the health of your cluster. And the third namespace is our application, right? So it's a typical application running several pods, a service, and an ingress. And the important thing about the ingress here is that K8gb is watching the ingress and the status of it. And based on that, it's updating not only the core DNS, but also the centralized DNS. One other thing about our application here, as you can see across the two clusters, we are deploying a shared app cache in Redis. So this is between both. We're just, for simplicity's sake here, there's lots of things you can do about replication, but we just have one cache. And what Crossplane is going to do is each Crossplane is going to actively or passively manage this. So the way this all works together, as we walk through all the different components, is that K8gb is monitoring both applications on both sides, and it's updating. If you look here at the DNS in the center, right, this could be anything, Route 53 Azure, and what this does is it sets up a zone delegation, right? So what happens is that when a user looks up the application, it looks up at the centralized DNS, and that DNS delegates to the ingress for the etcd for the active cluster, if that makes sense, right? So basically what happens is the user's DNS request will be forwarded to the active cluster's core DNS, and then once that comes back with the address, it will be the ingress of the application on that cluster. Okay? So these are the main components. Cross-plane provisioning, K8gb, which is actually updating the DNS and providing a DNS service on the cluster itself. Just a little bit about the components. As we said before, Crossplane is a universal control plane built on Kubernetes. Every single resource is modeled as a Kubernetes CRD. And as we said before, it's extended by providers and functions. And it's beyond the scope of this talk, but we're about to release some V2 APIs in August, which are going to be pretty amazing. It's really tailored towards right now, Crossplane is extremely strong about doing cloud infrastructure. This is actually going to make it very easy to do native Kubernetes resources directly. So a lot of folks, because for exactly this kind of use case where we're combining infrastructure and applications. Just a couple really things about Crossplane here. If you look at the CRD on the left, the CRD models APIs, this is an S3 bucket, right? So this is what actually a Crossplane resource looks like. And what you can see here, there's a for provider spec, and a for provider, a Crossplane CRD tries to model to 100% of what the remote cloud API is, right? So everything that you could get like from a Amazon or Azure API, Crossplane CRD will model it for a single resource. And then we talked about functions here. On the other side, what you see here is there's a pipeline. These are like GitHub actions that run within the cluster. And if you look at this, this is written in a language called KCL, which actually comes out of China, that we use a lot in the Crossplane community. And what you could see here is we have two regions. And what we do is we're just going to loop through those two regions and create an EC2 instance in it. Right, so with just a few lines of code, this will actually generate the YAML for two EC2 instances. Right, so you can, functions can be written in any language. You can mix and match them because we use all gRPC. So you can write functions in Go templating, which is very similar to Helm, Go language, Python, pretty much Q. So it has really good language support. Now K8gb. So the great thing about this project is you don't need to have like a cloud vendor's, proprietary global load balancer. This is actually like a shared nothing kind of architecture where you're running this on every single one of your clusters. There's not really a single point of failure. And it's fairly easy to set up and get going. There's only one CRD, which we'll show you in a little bit, that you need to configure. This is in the CNCF sandbox, and the community is growing pretty rapidly, right? I think there's...
We applied for incubating.
Yeah. It's this community is growing actually really nicely. So like Crossplane providers, K8gb also has a similar concept where it could use a bunch of external providers to update things, like Route 53 in Azure, and also RFC 2136 if you're doing like local DNS and bind. And it could run almost anywhere. Our demo is going to be on Yury's laptop, which is running K3S. Just a little bit about the load balancing strategies. It supports all the ones that you'd kind of expect. It does round robin. It does weighted round robin. And what we're going to show today is failover, right? Like based on app health, it's going to fail over. And then, of course, there's GeoIP2 that you could do where based on the incoming request, you could actually forward the request. All right, so we talked about K8gb provides one CRD, and this is it right here. And there's two things that are important about this. The first one in the spec is a resource ref, right? And this resource ref is the ingress that we want to watch. This is what you're telling the CRD to monitor. And the second one is based on that, what the strategy that you're going to use. So in this case, we're doing a failover, and then we have a geotag, which Yury could talk about during his demo, of how we indicate the load balancing. So this is what you need to do to configure K8gb. So now we're going to talk about how do we mix Crossplane and together. So we're going to have a demo. I'm going to briefly show you what we're going to talk about the demo. There's a pull request to get this merged into the K8gb IO repo. So we're going to have an active cluster and a passive cluster. And the active cluster will be doing all the work, even the Crossplane provisioning. So the first thing is we're going to provide our app developers. We talked about as a platform engineering team, we have to provide APIs to our developers. So in Crossplane, we're going to provide this concept of a global app. And you can see here there's going to be a region and a primary geotag and the host name and some other things that we could default, right? Like what's going to be the management policy, because Crossplane can have fine-grained management policies over resources, right? So we're going to tell Crossplane how to manage resources. So when we create this global app, what Crossplane is going to do is it's going to create these three things on the right. It's going to create the GSLB object, right, that monitors the ingress. It's going to deploy the Helm application, and it's going to provision the two Azure resources, right? So the developer is going to ask for a global app, and they're going to apply that to the cluster, however they do via Flux or Argo CD or just kubectl. And then Crossplane will come in and then provision all these resources. And then finally, what we want to do is we want to have this dynamic active-passive failover, right? Like we want this to be, and one of the cool things about Crossplane is it could respond to changes. Now with 1.20, it does this in real time, right? So when a status of an object changes, Crossplane automatically could run the function again. So we can get very fast updates, like almost instantaneously, to update other resources based on when the status changes on one. So what we're doing here is, if we start from the left to the right, the GSLB, we're monitoring the health status, and the way we're doing that is we're using a provider, a Crossplane provider, with a dynamic watch, right? So what it's doing is it's watching the status of that. And when the status changes, I've very simplified the function here. There's a lot of code in the function, but basically what we're saying is, in the function, we're flipping the Crossplane management policy. Right? We're saying if you're the active cluster, you have the full management policy. And if you're the passive cluster, all you do is observe. Like Crossplane, it could just observe and populate the status, but it's not going to manage the resource, right? So this will be the passive cluster. It won't be trying to change anything. And then once that's done, like whether it's active or passive, Crossplane is going to set the management policy on the resources. All right, and with that, this is what it's going to look like on the active cluster. It's going to have the 4 management policies, create, update, observe, and update. And then on the passive cluster, they'll just be observe. And with that, I'm going to pass it over to Yury.
Thank you so much, Steven. So let's run some live demo and see how it works in action. Can you please confirm that font looks like good for you as a rows in the back? All good? Thank you. So what we will have for the demo is 2 clusters, one in China, another one in Europe, and I'm going to switch between them during the demo. And so I have some highlighting banners so we can follow the context in which cluster we are and not get lost during the context switch. So first thing first, what we have on a primary cluster in China. We already have Crossplane and K8gb installed, so they are all located in associated namespaces. Everything is prepared. K8gb is also there, and we have all Crossplane dependencies already running. So we have a composition, definition, and all that things. So what we first already instantiated on that cluster is this spec. So it's global app that Steven already mentioned. So we instantiate this global app. We are telling infrastructure region to be like somewhere close in Azure. We pinning the primary geotag for a failover strategy to be in China. As we in KubeCon China, it makes sense. And we specifying the standard namespace for our application. We specifying the global FQDN. So it is global FQDN. So when client accesses the global app.cloud.example.com, it's going to be steered somewhere by KGB using this smart DNS global traffic management capabilities. And this is Crossplane chunk of spec. This is something that drives the initial management policies. So what Steven mentioned as a call array, observe, create, delete, we can just replace by star, meaning that the Crossplane can take over the full control over the external resources. So, and the last one of the spec is how to apply these management policies according to the GCLB status in a fully automated manner. Sometimes we want to disable it to override the management policies manually, but here we are going to fully rely on our controller and Crossplane composition logic. So that is what was instantiated. Let's check it out. So it's already there, prepared for inspection. And what we can do is a standard Crossplane beta trace and see what was instantiated. And okay, I have some connection issues, unfortunately. But let's stick with a demo flow. So the idea here is that global app is composing the external resources, and maybe currently I do not have direct accessibility to Azure. I'm not sure, we'll figure out. But first we composing the infrastructure resources, a release, Helm release, with provider Helm within a cluster, and object which is that represents the GCLB status. So we can describe this object of a failover ingress, and that's exactly the GCLB kind that is getting reconciled by a KGB controller. So that's what exposes the current global load balancing strategy and the status of the resource. So if you look at the demo namespace, we can see that the pod of the application is there around, and the GSLB is also instantiated. So currently, it's this GSLB that was created by a composition. So it is failover strategy, right? And currently it's in healthy state. So it monitors the application health status transitively through the ingress. Okay, and usually we don't need to dive into the low-level resources. It's just enough to get this global app and look around its status. So let's see the status like in YAML. And our global app abstraction is intentionally pretty verbose. So it tells us that the infrastructure is ready. It tells us that Redis cache is available for our application, and GSLB resource is created by the composition logic. And now one of the most interesting parts from a failover activity is GSLB, right? So it reads the GSLB status, GSLB resource status, and figures out the current healthiness of the current application deployment. So according to the current setup, all GSLB domains are healthy. The IP addresses of exposed IPs and healthy records from GSLB standpoint are matching, meaning that our current cluster is active, and we effectively applying the management policies star, meaning because the current Crossplane instance is going to be operating in read-write mode. So taking over the control over the Redis and cache and resource group. So we can double check that, like for example for resource group, we can check that the management policies are star, right? So it's propagated down to the associated managed resources. So that is a representation of external resources in our cluster. So, by the way, we can double check what's happening there. Still don't know, but so far so good. It reconciles. Not sure why Crossplane beta trace returns this sync error. So now, our cluster in China is active. What's happening currently in European one? So we deployed exactly the same spec with small difference. So it is passive. So it's exactly the same spec as before. We just providing the initial management policies in observe mode, so we do not clash. And this one, this control plane is supposed to be passive, so it operates in read-only mode. So what does it mean? We can get a quickly global up here. So we are getting global apps, and we also inspecting the status. So here, this current cluster treats to be active, which is not incredibly expected. So let me double check the context and get a global app again. Okay, here we actually were expecting it to be in a observe mode, and that is interesting. That is like a demo failing for me, but the overall concept here, I hope it is clear. Anyway, what we are going to do, we will not surrender to the circumstances, and we will switch to the Chinese cluster and see how it will behave right now. So currently we are running this endless curl in a parallel terminal and querying the global app. So currently failover is pointing to the primary cluster, which is in China, and we can emulate the outage in a primary cluster by scaling the things down. Okay, and now we can immediately see that traffic was actually steered to the European cluster because the application is not healthy. And we can check the global app. Now it flipped to the observed management policy, and we can double check that on one of the managed resources. That management policy is also observed. So what does it mean? So we switch the traffic to from primary to secondary cluster, and the problematic cluster became read-only, right? So it just pulls the data from the resources, and now European cluster took over the control. So now, like as we see, like it's a read-write mode, so it didn't supposed to have a read-write mode initially. So something during the state was transitively like judging the state incorrectly. But in any case, KGB works perfectly now and pointing to the secondary cluster and returning the traffic from the currently active one. So now let's switch back to the cluster in China and fix the outage, right? In our case, the simulation will be simple. We will fix it by scaling the replicas back to 1. And we will face some 503. Sometimes it happens because we are still limited with the DNS TTL. Sometimes we can hit the temporary not working fully yet application, but for global scenario it's totally fine. It's acceptable window. And here now, after we fix the application in the main cluster, the cluster was brought back and the traffic steered to the healthy application in the primary one. So now everything worked, so like we can fail over and automatically steer the traffic globally between globally dispersed applications and clusters, and Crossplane is also aware of the GSLB status and flips the management policies accordingly. So we can double check global app. It should switch the status back to the to the star, to the management policy of read-write, so it took over the control of the external resources back. So now, super quickly, how it works. So we have a standard XRD. Sorry, my terminal fails me a little bit. Let's reset it. We have a standard cross-plane setup, right? So we have a definition of a global app, so it exposes this custom API, and the main logic from Crossplane's standpoint is within a composition. So we have 3 pipeline steps. First one, creating infrastructure. So here we can see that we creating this resource group and a Redis cache, the shared Redis cache. The second step would create a local application within a cluster on both clusters symmetrically and propagate the associated Helm values with the provider Helm of Crossplane. And here we populating the different data like a region and a custom message. And on a third step, on application step, we also creating GSLB resource, and in the third step, we monitoring this GSLB resource and creating this custom logic where we treating the GSLB, we reading the GSLB state, and this way we are judging which cluster is active and which management policy to apply to underlying Crossplane resources and expose the status back. So that's it for the demo. We managed to steer the traffic between primary and secondary cluster and back. We had some glitch with associated secondary cluster state, but it was secondary, maybe some networking stuff that failed us, but the main core of the demo and the traffic management worked. So back to Stephen. Thank you.
Yeah. So really, I think that's the end of our demo, but just wanted to talk about some things that are coming. In this example, we embedded a lot of the logic inside a KCL function, but for reproducibility, we'll probably be releasing a native K8gb function that can do this with Crossplane. I think there's a lot of interest in doing a dashboard for this, so that's one thing we're also looking at. And then finally, we talked about Crossplane v2. There'll probably be a lot of other talks related to that as it comes out in August, but one new feature is going to be things like operation functions, which means when certain states change, you could actually kick off jobs in the cluster. So, based on what happens during a failover event, you could do it. We could kick off certain actions. And with that, I think we have a couple minutes to take questions.
Thank you.
Yes, thank you very much.
Any questions on implementation or concept or anything? Any of the projects? Yeah, please. Right.
I believe your question is we have one Redis instance for 2 clusters, right? Is that correct? Yeah.
Yeah. Yeah, so this Redis is intentionally kind of shared because we are demonstrating like 2 clusters and a shared infrastructure. Is definitely we can potentially modify this Redis cache to be also geographically distributed. But this is like this specific setup was to demonstrate that Crossplane can modify the management policies across 2 different clusters and actually have this kind of global state and active passive mode. So actual like a specific implementation of Redis, it's up to you, right? So you can tweak it. It can be actually not Redis, but some databases, and it can be separate databases per region, and then you figure out the data sync and the backend on a database level. So that's the infrastructure part, yeah. Yeah, thank you for the question. Please.
Does Crossplane has any plan or roadmap for AI-related functions?
AI related?
Maybe some combination of other AI project?
I think we actually have a prototype of AI-based function, right?
Yeah, I think.
Yeah. Yeah?
Yeah, I think there's some Gemini support coming in the providers for Azure, and then probably a lot more stuff coming in this area. I know that's very active in the community. There's just stuff we're aware of that hasn't been announced yet, so I think you'll be seeing a lot in the next few months.
Anybody else?
I have a question that the class A and B work as the failover mode or load balance mode.
This one was failover for active passive.
As I think the failover mode seems a little waste because only one serves, right?
Well, that's up to you for implementation, but in this case, we have a globally available Crossplane, right, in a standby mode. And this way, you actually avoided the need of, super active frequent backups, and you have a globally available application that is ready for you. So this actually mode, deploying application in at least 2 different geographical locations come from a real financial organization operation mode. That's where the KGB was originally created, and I think it's pretty popular amongst the banks.
Thank you.
Thank you.
I believe we're at time.
Somebody else? Can we handle a couple of more questions?
So I think the underlying failover mechanism still relies on DNS, right? So how do we mitigate the DNS TTL issue?
We can't. So the only thing that we can do is actually reduce the TTL window. So and the lowest, as you know, is 30 seconds, but it's too aggressive. So in actually real operations on large scale, I noticed that operation team are actually raising it to roughly 1-2 minutes, and it's totally okay for a global failover in actual scenario, right? And now this for global means some serious disaster, so 1-2 minutes for recovery, it's actually frequently acceptable. So,
so basically, we still cannot avoid some downtime for some users.
Well, minimum downtime in a global failover scenario will be there. If you apply different strategies like, round robin and spreading the load across the global geographical dispersed location, then there is a way to mitigate it, yeah.
Yeah, thank you.
Yeah, thank you. Great question. Right to the core, yeah. Anybody else? Nope, none. Thank you so much.
Thank you, everybody.